Y has 6 valence electrons. Y react with fluorine gas to form YF2 and YF6 compound. For each compound, draw the Lewis structure. The information given, which one? Draw the Lewis structure. One Roman Lewis structure for each compound. Say that each compound. So we have to draw the Lewis structure of YF2 and YF6. So here, before we draw the Lewis structure, we have to know we can write the valence electron and then the total valence electron. So for the YF2, you can draw it like this. So we have to make the terminal atom. We have the octet number of electron, 2468 and then 2468, and then now we have 8 plus 8 is 8 plus 8 is equal to 16. So the total valence electron in this compound must be 20. So 20 minus 16, we have 4 left. So another 4 electron where to put is at the central atom, which is, you can put here, or you can just put it here and here, but I want to put it here. So for compound YF6, so the central atom is Y, and then the terminal is fluorine. So before we put another electron at the central atom, we have to calculate all the electron. So 2, 4, 6, 8. So 8 times 1, 2, 3, 4, 5, 6. So 8 times 6, we got 48. So already total valence electron. So the central atom does not have any lone pair lah. So done. Draw the Lewis structure. As for number 2 Roman, predict the electron pair arrangement and predict the Lewis structure is done. Predict the electron pair arrangement and the molecular geometry. So number 2 Roman. Don't forget we have to do for the both compound, which is YF2 and YF6. So we do for YF2. Now, and then okay. So YF2 we have the class is AB2, E2. So basically from the class, how we determine the class is by looking at the Lewis structure. So class A is the central atom, and then B is bonding pair, E is one pair. So B2 bonding pair got 2, 1, 2. So right here bonding pair 2, and then E is 2. So E got lone pair 1, 2. So lone pair got 2. Total electron pair is 1, 2, 3, 4. Electron pair is bonding pair plus lone pair. We got here 4. So electron pair arrangement is tetrahedral. And as for the molecular geometry, is V-shape. Why is it V-shape and not tetrahedral? So for the molecular geometry, we ignore this one, and then it will look like this. Okay. Like this. So you like V inverse. V like this, or you can just they just same. So as for this one, so the class is, you can see here, A. So we can write the bonding pair, which is 1, 2, 3, 4, 5, 6. So B 6. We got any lone pair here? No, right? So E is equal to 0. So we don't need to write any E. So just the class is A, B, 6. So for the bonding pair, we got 6 bonding pair. Lone pair is 0. So the electron pair is bonding pair plus lone pair. So equal to 6. So electron pair arrangement is octahedron. Octahedron. And then the molecular geometry is the same. Okay, to make it easier for you to memorize the electron pair arrangement and the molecular geometry, how we know that if the molecular geometry is different from the electron pair? So for me to memorize it, so like this, you can see that the molecular geometry and the electron pair arrangement is the same, which is octahedron. So as for this one, is the molecular geometry and the electron pair arrangement is not the same. So if it have any lone pair, the molecular geometry will be different from its electron pair arrangement. For this one, you can see that molecular geometry is the same because the compound, this compound, doesn't have any lone pair. So the electron pair and the molecular geometry is the same. So next, this one is 10. Draw the molecular geometry and state its bond angle. Bond angle, then molecular geometry. So from the two Roman, we already know the molecular geometry, which is V shape, and then the molecular geometry for Y F6 is tetrahedron. So for 3 Roman, you can just draw the molecular geometry. Less than 109.5. Here. The bond is here. Less than 109.5. And then for the YF6, two bond angle. One is 180, then one is 90 degree. So where is the angle actually? One is like this, is 180, and then one is here, 90 degree. The type of hybridization of Y atom. So type of hybridization is 4. How do we know this? Go back to the two Roman, which is already right here. Electron pair is 4. So type of hybridization, sp3. Number of electron pair, we check back at the two Roman, which is 6. Hybridization is sp3d2. So for me to know what is the type of hybridization, you know the total number of electron pair, which is 6. So we have this 1, this is 3. E, S, 1, S, 1, P, 3, D, 5, right? So we know that this S is 1. P can put 3 total electron pair. P block have 3 electron pair. S block has 1 electron pair. D have 5 electron pair. But here, we know the total number of electron pair at the central atom, which is Y, is 6. So this is 1 plus 3 plus 2. So 1, 3, 2 is equal to 6. So if the total number of electron, what is number here? So we can get this. And then we know the hybridization. So for this one, total number of electron pair is 4. Then the type of hybridization is this 1, and then this is 3. So sp3. And of A, we move to B. The question asks, based on the structure of element, explain why the boiling point rises from sodium to aluminium. Sodium to aluminium. So we know that sodium to aluminium. So all of this is metal. I want to change other color lah. Color orange. All of this is metal. Metal. Therefore, when all of this is metal, it can bond metallic bond. So when they can form a metallic bond, what is a metallic bond? Metallic bond is an electrostatic forces between positive metal, change the color, positive metal ions and C of the localized valence electron. So we can draw like this. For example, you have sodium. Sodium is an A plus. And then right here, an A plus, an A plus, an A plus. Here, so this one electron is called as C of the localized ion. Okay? D C of the localized valence electron. So this one is the positive metal ion. So strength of metallic bond is proportional to the number of valence electrons in the metallic atom. So this one is 4, 1, 2, 3, 4, 1, 2, 3, 4. So the strength of metallic bond is high. So the number of valence electron may be increased respectively. So therefore, this one is plus 1. This one is plus 2. This one is plus 3. Right. So it will be increasing. Because I see here, strength of metallic bond is proportional to the number of valence electron in the metallic atom. So this one is positive 1, positive 2, positive 3. So we can see that the boiling point will be increased from sodium to aluminium. That is the increase. So to write it, you can say that like elements from sodium to aluminium are metals. In metal, the atoms are held together by strong metallic bond. So metallic bond, we say the what is the meaning of metallic bond? Metallic bond is an electrostatic forces between positive metal ion and C of the localized valence electron. Strength of metallic bond is proportional to the number of valence electron in the metallic atoms. Number of valence electron of sodium, magnesium, and aluminium are 1, 2, and 3 respectively. Same as this one I said. So, thus, melting point and boiling point increase from sodium to aluminium. It's easier for you to understand it by drawing. First, you do like this. What? First, what is what? So, like this. Sodium, magnesium, aluminium is metal. And then, sodium, aluminium, sodium to aluminium is metal. So, when it is metal, what bond can it produce? What bond can it make? So, a metal can make a metallic bond. So, then you explain what is metallic bond. What is the relationship of metallic bond with the boiling point or melting point? So you can say that this one, the strength of metallic bond is proportional to the number of valence electron. So when you understand this sentence, strength of metallic bond is proportional to the number of valence electron in the metallic bond in the metallic atom, you can understand why is it increasingly like this. Because sodium is plus 1, magnesium is plus 2, aluminum is plus 3. So it's take here, metallic bond is proportional to the number of valence electron. So here got more metallic bond rather than sodium. So more energy is needed to break the bond. Therefore, the boiling point increases from sodium to aluminium. So for the Si, why it has the highest boiling point? First, you have to know the element exists in what structure. For this one, Si exists in gigantic covalent structure. Therefore, it has a strong covalent bond holding the atoms together. Therefore, when it has strong covalent bond holding the atoms together, it has more energy is needed to break the strong covalent bond. So when more energy is needed, it automatically has more high. When it has more energy needed to break the strong covalent bond, therefore, it has the highest boiling point. Alright, that's all. Thank you for watching.